Hello everybody, this video is about probably the most asked question from our homework assignment. It's about the box plots and the variables associated with them and the interpretation of median, quartiles, and dispersion and things like that. So before we do this problem here, I want to remind you that this here is what we call a box plot. Sometimes you say is a box and whisker plot. So again, you'll hear us say it's a box plot because it uses boxes, or you might say box and whisker plot. And again, the word whisker is referring to the kind of the tails, or like the whiskers on a cat or some lion or tiger there. So that's where the whisker comes from. And so just to remind you what I'm talking about from our lecture or from the lecture notes, looking at your lecture notes here from this section here, a box plot is created via a 5-number summary, and that 5-number summary contains 5 numbers from some set of data, which are the minimum, Q1, the median, Q3, and maximum. All of those are quantitative values we can get from data. Q1 is also known as P25, or the 25th percentile. This is known as the median. You could also look at this and say this is P75. Some people would ask, is the median also P50? And the answer to that is yes. We've talked about in the last lecture and from your notes there. And so this is what a box plot is made up of. It's made up of those numbers there. So we go and take a look at this question here. These values here, this number here would be the minimum. This number here is the median. This number right there, let me change colors with that. This number right here and right here, this number here is what we would call Q1, or the P25, the quartile. 25th, the first quartile here is what we would call Q3. And the same is true here. This value here would be what we call the max value. And so looking at that, that's how the box plot's created. So to the nearest integer, what is the median of variable x? And so we would look right here and we would say that that value is approximately 40 for the median, looking at that line and how it lines up. To the nearest integer, what is the third quartile variable y? So looking at the quartiles, again in quarters, first quarter, second quarter, third quarter, this is where we would find our quartile. And so I would say for that one there, it's approximately 52 to 53, probably somewhere in there. Maybe 51, but about 52 to 53. Which variable has more dispersion? That's an important word for us, right? This dispersion. That is an important word there for us. When I hear the word dispersion, another term that we've thrown out in class is called dispersion is called spread. And so another word for dispersion is spread. How spread out are the values? And we've talked about that concept in class. And I would say in this case here, variable y has more spread. And you can see because look at the range of values. It goes from the range here. Why is that? Because the range is equal to, if you look carefully, from 0 to 110. It's like 110 approximately. 110 minus 0, which is like 110, compared to the range here. If we looked at this one and looked at the range here, the range is equal to like somewhere 15 to 70, from 70 to 15, or approximately, again, these are approximate values since I don't have the exact values, but 55, so this has more dispersion. Describe the shape of variable x and y. Describe the shape for x and y. And to do that, we would then go back to just refer to our notes in class from the lecture. And down here in the bottom, the last piece of these notes, we talked about these spreads here. We've already know that this picture here is a skewed, when we talk about the shape, right? When we say what is the shape, we're gonna use terms like normal, bell shape. We're going to use skewed. We could say skewed left. So when we're talking about shape, that's the language we're going to use. We can say skewed right. We might even say uniform. But in this case, here are 3 examples from our notes again. This is skewed to the right. This one here is we would call normal, and then this one here is skewed to the left, and it's based on where the kind of tail is. And so then you can look at those pictures here of look at these pictures here and see like there's a longer tail. The whisker is longer here, so it's skewed right. The whisker is longer here, skewed left, which then will allow us to answer those questions from homework. Looking at this here, describing the shape of variable x, I would say variable x has a normal shape, and in the shape of variable y, there's a longer whisker to the right. So we would say this is skewed right. That's it.